I am Hiroki Uto from Japan. I belong to Nakashimada Engineering Works. Today, I speak about our deorbit device, DOM 1500. Here is here is the outline. I explain the background, design requirement, specifications, DOM in action, developmental status, and conclusion. Initially, I explain the background. In recent years, the number of microsatellites is increasing. The mitigation of space debris becomes more important. IADC guideline recommends a microsatellite should deorbit within 25 years after its operation phase. In 2010, Nakashimada Engineering Works and Tohoku University started to develop the orbit mechanism. Its short form is DOM. This picture shows the first concept model of DOM. In 2014, the development of Freedom was started. Freedom is a 1U CubeSat specialized for DOM demonstration. This is the external view of Freedom. The mission of Freedom is to demonstrate DOM for use in 50 kilogram class microsatellites by a 1U CubeSat. Freedom deploys thin film and re-enter the atmosphere of the Earth. We had some requirement in designing DOM for Freedom. DOM for Freedom must fit into a CubeSat and should be mountable inside PAS239M. PAS239M is a rocket interface cylinder for 50 kilogram class microsatellite. Film size should be effective for 50 kilogram class microsatellites. Mechanism should be as simple as possible. DOM for Freedom should have a double redundant switch. We call DOM for Freedom DOM 1500 because its film size is 1500 millimeters square. Next, I speak about the specifications of DOM 1500. DOM is a short form for the orbit mechanism. The number 1500 represents its thin film size which is 1500 millimeter square. DOM 1500 is a device which deploys a thin film, increases atmospheric drag, and make microsatellite deorbit rapidly. These pictures show the external view of DOM 1500. The left is before deployment, and the right is after deployment. DOM 1500 is 110 millimeters in diameter times 73 millimeters in height. While a 1U CubeSat is a cube 100 millimeters on a side. However, CubeSat standard permit protrusions less than 6.5 millimeters. This blue volume is the envelope for protrusions. Therefore, DOM 1500 fits into a 1U CubeSat. The diameter of DOM 1500 is smaller than the inside diameter of PAF 239M, and we designed an interface for 50 kilogram class microsatellites. Therefore, DOM 1500 is mountable inside PAF 239M. This is PAF 239M, and DOM 1500 is mounted inside. The mass of DOM 1500 is 1000 gram, including the margin of 60 gram, while the maximum mass of a 1U CubeSat is 1330 gram. Therefore, DOM 1500 fit into a 1U CubeSat. Here is the weight budget. DOM 1500 consists of main structure parts, convex tapes, thin film, and so on. As I mentioned before, the film size is 1500 millimeters square, and the center cut off is 500 millimeters square. And we calculated the lifetime of a various size satellite. The initial condition is given in the DDC call for papers. Here is the result of the calculation. The blue bar shows the lifetime of a satellite when DOM is not deployed. And red bar shows the lifetime when DOM is deployed. The lifetime of a satellite is considerably shortened. Therefore, DOM 1500 is effective for DDC initial condition. We also calculated the lifetime of 50 kilogram class micro satellites at various initial altitude. Here is the result of the calculation. 25 years is mentioned to be a reasonable limit according to IADC guideline. As the result, DOM 1500 is considered much effective for 50 kilogram class micro satellite at initial altitude lower than 700 kilometers in height. DOM has a very simple mechanism. Two wires made of polyethylene hold down the contents of DOM, and joule heat of a register cuts these wires. These pictures show a deployment mechanism. First, external battery provides electrical power. Next, heat of register cut the wires, and a coil spring pushes the contents of DOM out of the container. Last, convex tapes and film are deployed. This diagram shows electrical system of DOM. DOM has two registers as deployment switch. An external control unit turns on the switch. Whichever switch is turned on, DOM is deployed. The resistance is 4.7 and 6.8 ohm. The required voltage is 5 volt. This is a figurative model of DOM switch. DOM contents are fixed by two wires. One wire alone is strong enough to withstand launch environment. Two registers are, as it were, two pairs of scissors. Either scissors can cut both wires at one time. This is a video of DOM deployment. Sorry, video is stopping. I skipped the video. Okay, thank you. Sorry. At 0 second, a battery provides electrical power, and after 35 seconds, the wires are cut by the heat of resistor, and DOM is deployed in a moment. This is developmental status. We finished developing DOM for freedom flight model at the end of 2015. Now, DOM is in a stage of demonstration in space. Freedom will be handed over to JAXA and will be delivered to ISS and to be deployed into space in this year or in next year. In the future, we should verify DOM deployment after exposure to space environment, and we should estimate the additional level risk. For example, breakage of film or collisions with debris. In conclusion, DOM 1500 is a thin film deployment type deorbit device. DOM 1500 increases atmospheric drag and makes a microsatellite deorbit rapidly. I'm sorry. Primary specifications are shown in this table. I show the initial design requirement in this table again. The initial design requirements are satisfied. Thank you very much.
Thank you very much for your presentation. So it's time for question now.
I think you misunderstood one of the requirements. I agree that DOM will work very well in a microsatellite of 50 kilos. But if you want to deorbit the 1U CubeSat, it will be too big. It's the size of a 1U CubeSat. So the requirement is not that it must be the size of a 1U CubeSat. The requirements were that it can deorbit a 1U, 2U or 3U CubeSat. But it's fine, I just want to mention that. The requirement was really that how to deorbit a CubeSat, either 1, 2 or 3U CubeSat. DOM will be able to deorbit the 2 or 3 unit CubeSat as long as you're prepared to sacrifice a 1U volume, because that's the size of DOM. It's a 1U CubeSat volume. Yeah, okay, so if you could follow what I asked, it's just a observation from my side. He doesn't really need to answer that, but...
requirement.
Yeah, it must fit into a 1U CubeSat to deorbit the 1U CubeSat. So. Yeah, it's not the requirements of the competition.
But if there are verification about those 500 is available for the
What's the size of DOM 500?
So my question is DOM 500 because the detail is not written in the program. But I think so.
Maybe you can comment on that. What is the size of DOM 500? What is the size?
1500.
No, 500.
500.
DOM 500.
In your paper.
In your paper, you mentioned that you can use DOM 500 for smaller satellites.
We developed DOM 500. DOM 500 is a small size DOM. DOM 500 is 80 millimeters in diameter and 45 millimeters in height.
So about a half U. It will fit half U of a 1U satellite.
How effective the DOM 500?
How effective か。確かにね。DOM 500 has a thin film. Its size is 500 millimeters square.
Did you do simulations? I saw you made a simulation of 1500, but did you do simulations of 500? That one. If you use 500, how much it will be?
I can calculate the lifetime of the satellite with DOM 500, but the lifetime calculation has not been calculated yet. I'm sorry.
I think 2 points. It is kind of expensive for CubeSat. The cost even in the.
Sorry, we cannot mention that before.
And another thing, since it's heavy for 1 2 unit CubeSat, I think effect of center of gravity. That's also another point.
Cost is important, I think. Yeah. But we cannot mention that right now because after going into space, we have data, we have to see or accounting side as a breaking into employee or something like that.
Any other question? Okay, let's thank again our presenter.
Thank you very much.